Hello everyone, I'm Arindam. I'm back again with another video. Today is August 19th, Tuesday, and here I am. So, I was working on one of my assignment where I had to work with Power BI. And honestly, I have lost good touch from Power BI. It's been a while that I worked on Power BI. So I thought, why not? Let's make a video on this, right? So today we will discuss about much talked topic called data modeling. So it's an important topic. It's an easy topic, but that is at the same time it can be confusing if not understood well, right? So I'll try to put things in layman term with and keep the terminologies as intact as possible. Now there are other topics as well in Power BI like DAX and calculations, right? But let's talk on that sometime later, and let's talk on data modeling today, right? So let's get going with our data modeling topic. All right. So I created this PPT in like 45 minutes. Try to keep it as simple as possible and just the necessary topics. Just all the topics in data modeling I have covered. Right? It's the topics and it's metadata bullet points. Right? Microsoft says my modeling spelling needs a fix, but yeah, whether if it's a single L or a double L doesn't make a difference. Still gonna be modeling. All right. So what do we have here? So we'll be discussing about you know uh, different table types, relationships, cardinality, right, and cross filter direction. Then we have got schemas, right, and we'll talk about relevant performance optimization. Okay. Alrighty. So let's start with our types of tables. Okay. In here we have got fact tables, dimension tables, and bridge table. Right. So what's a fact table? Let's start with the fact table. Right. So what's a fact table? So imagine you have got different data sets. Okay. Now, how would you identify if a particular data is going to be a fact table or not? Okay. So easy way to remember this is whenever your table or your data set is full of numbers like actual measurable values, then that's gonna be your fact table. Alright, so anything numerical value or something that can be measured is going into your fact table. Now the most simple analogy would be, think of it like this, that let's say you run a restaurant, you have got a data table, right, showing daily sales amount. Okay, so that's a fact table. Okay, then you have got your inventory data, right? So number of items coming in, number of items going out, stuff like that, right? Your inventory stock levels, right, goes up and down. You can measure it. It's quantitative, it's numeric, right? That's again your fact table. Okay, if you want another example apart from this, think of it this way, that you're working for a weather department and you get a data set of getting tracking of rainfall every month, right? How much it has rained on this particular day and for every day for a month, right? So how much it has rained, you're keeping a track of it. All that, it's a number. You can measure it, you know. So yes, that's again your fact table. Okay. Now these fact tables, right, all about quantitative data. We understood so far, right? And because the values keep changing, right? Like for example, sales going up and down. One day you might have good sale, one day just another day you might have, you know, sales going down. So all that keeps changing, right? So these fact tables are also called transaction tables. Clear? Next. Now, fact tables, okay, don't just sit there alone with quantitative or measurable values. Okay, they also come with something called as foreign keys. For example, let's say columns over here. Okay, let's say you have got sales key, date key, store key, all these things. You see over here, transaction key, customer key, salesperson key, so on. You have got, okay, all these are foreign keys. And along with these, obviously, you will have your, you know, metric data as well, like, or measurable data as well, like unit cost, unit price, sales quantity, and so on. So in a fact table, you'll have your foreign key and you'll have your measurable or quantitative data as well. Okay. So, you know, these foreign keys help them connect to other dimension table. If we do not have these foreign keys, we will not be able to connect to our dimension table. Okay. Now, we know that fact table have foreign keys along with measurable quantitative data, and these foreign keys will help us connect fact table to dimension table. But what is dimension table now, right? So we have understood till now that fact table contains measurable values or quantitative values. They have foreign keys which help them connect to dimension table. The values in the fact table are highly variable. They keep changing, and that's the reason they are called transaction table as well. Now, what is dimension table? Okay, let's go ahead and check dimension table. Now, so unlike fact table, which will mostly tell us how much, right, you know, how much in terms of quantitative or measurable values and so on, right, the dimension table will tell us what it is. So dimension table, or which is also called master table, like the fact table is called the transaction table, dimension table is called as master table, right? Now dimension table will tell us what it is, right? Now this will give you description or more information about a particular column or attribute. So whenever you have columns or attributes like customer details, item details, or some category, right, or you can have subcategory, right, then that will be your dimension table. Okay. And unlike fact table, your dimension table will have primary key, right? So these primary key of dimension table will connect to the foreign key of your fact table. Okay, right? So this was about our fact table and dimension table. Now last type of table which we have over here is bridge table, right? So as name suggests, right, what it is doing, right, it is like a mutual friend who connects two people, right? Or someone probably just being a third wheel. If you know, you know. So never mind. So let's see what exactly it means when in the bullet point, when I say it handles many to many relationship, right? So we'll also discuss about relationship later in the video. Now, a bridge table helps when we want to show that one thing can have many other things and vice versa. Let's see a simple example over here. Okay, so you have got students, right? You have got students table with all student details, right? That this one is your student tables, right? And this is, let's say, is your subject table. Okay, so student table with all the student information and subject table with all the subject info, right? Now in real life, each student can be enrolled in multiple subjects, right? And each subject can have multiple students, right? Isn't it? So this is our classic many to many relationship or many to many setup. But in Power BI data modeling, there is a problem. When we go and create a relationship between these two tables directly, right, the Power BI machine gets confused and we will get wrong results. Therefore, we need to have a bridge. And what will this bridge have? What will this bridge table have? It will just directly have student ID, right, associated with subject ID. That's it. No other metric, no other column or attribute. It's just a clean middleman that helps both tables talk to each other properly. Okay. All right. So we have seen what's a fact table, what's a dimension table, and we have also seen our bridge table, right? So bridge table again, it'll handle many to many relationship, because two tables which have many to many relationship, they cannot go ahead and get connected together, right, directly. So a bridge table will help two dimension tables get connected indirectly. As simple as that, right? So we are done with our table types, right? We have seen fact and dimension table, we have seen bridge table, how it looks, and then we have something called as relationship and cardinality, right? So here we will discuss how tables are connected, right? That's your basically relationship. We'll see about different types of connectivity, or say cardinality, one to one, one to many, many to many, right? And how direction of relationship is important, right? Filter, as you can see, cross filter direction. Okay. All right. So let's understand it this way. So in Power BI, relationship is giving connection between different tables, or say linking multiple tables on a particular column shared by both tables. Okay, this way, this which you see over here, we are giving relationship. We are connecting this student table with enrollment table, and this we are giving a relationship on what? On student ID. That's our common column name, right? Now when you hear the word connecting, linking, or merging, we are not doing actual operation of joining the tables or merging the tables, right? We are joining them on model or say just on visuals, where in the join or merge we are actually combining two tables, right? If you see in SQL or Python, right, where you are when you join or merge, we are actually combining two tables to make a bigger table, right? But we are not doing that over here. We are just connecting them, right, on visuals, on data model, right? So we now know what is relationship in Power BI, right, or data model. So let's get going with our next topic. Right, now before we jump to another topic, which is cardinality, we need to understand why this relationship is actually important. So for that, let's just have a quick example. So I've got a customer table over here, and I've got a sales table over here, right? So I can link both the tables on customer ID, right? This customer ID and this customer ID. I can link both the table and create a relationship on this particular column. Now, why this is important? This is important because when I'll be going ahead and creating a report, I can visualize total sales based on customer city, and I can do much more visualizations or create reports through this relationship that I have created. If I don't go ahead and create a relationship and I just directly jump on to create the visualization, the Power BI visualization part will be confused and will not be understanding from where to take information, right? So how we take other table information to create a chart or a report, that is why the relationship is really important. Okay, so we have understood what is relationship and why it is important. Okay, so next up, we are done with relationship, and let's move to how we can actually create it. I can just quickly give you a demonstration on Power BI if you are on this, right? All right, so we are here on my Power BI. So I had already created this model relationship between tables long back, right? And I had worked on this very basic project, right? So I'm taking this for demonstration purpose and example, right? So over here, let's see, all these connections, the lines that are going from one table to another is basically a relationship. How do we create a relationship, right? So let's say I have gone ahead, and you can see that this is here. So you can see from here this is going. Now if I hover over here on this particular line, right, I can see which two columns have the connection, right, or the relationship created. How do we create? What I have done, I have just clicked on this date and I have dragged it to return date, and that has created a relationship. Okay, that's one way you can create a relationship, right? Now I have a couple of options as well. Let's say I go ahead and click on this manage relationships over here, right, and I'll get all my relationships that are there, right? So now I have two options in Power BI. A great feature, right, provided by Power BI is either I let Power BI create relationships or I do it manually. So if I want Power BI to go ahead and create it, I can use auto detect, okay, or we can go ahead and do it manually. You can use auto detect. It's a great feature by Power BI. However, there is a catch that if, let's say, your columns in your tables, the columns name are different. For example, this is the best example, right? So if date and return date, if the column names are not similar, are different, right, then in that case the auto detect will not link them. But we know that these should have a relation created, right? But because of the small change that the column name is different, it will not link them, right? So you have to go ahead and do it manually. Okay, so over here, same way, you must be seeing in the managed relationship, you must be seeing active and inactive, right? So what are these active and inactive? So let's say I want this date column to go ahead and get linked with not date column. Do we have any example? Okay, this is good example. So I have this date. So here I have linked date and order date key. Okay, now if I click on this, you can see order date key and date. Okay, I have linked these two, right? Now what if I want this date, okay, to be linked to my ship date key or due date key? Then what in that case? Okay, so I'll go ahead and give a relation to ship date key. Okay, and then I can click on save and a relation will be created, right? But remember this, that a table can have just one key active. Okay, I can keep only one active. I can go ahead and create two relationships or two connections, but only one can be active and the other one will be inactive. So if I want to use to visualize my information for between calendar and for this ship date key, I will keep the ship date key and date column active, and I will inactive the previous connection, so that I can use ship date key information in my visualization. Okay, or else if I need to use order date information, I can go ahead and make it active and make then the ship date inactive, right? So you can create multiple connections between two tables, but only one will be active, right? Alright, so this was about active and inactive in Power BI. Okay, you see here manage relationships. This is the table, and over here we have got our auto detect, right? And these are active and inactive, right? And how we can go ahead and change the status. We can change the status from here. If you have multiple connections between two tables, that's how we can do it. And what you can give a try is you can also use DAX formula to make a relationship active or inactive. You can give that a try using DAX formula. The formula is, I guess, use relationship. And other thing is that whenever you have loaded your data, you have done all the transformation, done everything, you have applied it, you have loaded the data into Power BI from Power Query, then just go ahead and run an auto detect and see what all connections the Power BI is automatically giving. Okay, and then if there is anything left which you think needs to be connected, you can go ahead and connect it manually, right? So this was about relationship in Power BI, and next up we'll see cardinality and what's that in the cardinality. Okay, alright, so yeah, done with relationship and how tables are connected. Now it's time to understand cardinality, one to one, one to many, many to many, and it's time to understand cross filter direction. So before we proceed ahead, what is cardinality? So if you just go ahead and Google what is cardinality. Then you would see, give me a moment, cardinality. Okay, the number of elements in a set or other groupings, right? So over here, okay, so let's see. So what does this mean, when we say number of elements in a set or other grouping? So basically, how many elements in a given relationship. So I would stress again on the part that says how many, right? So reason being, and let's take an example as well, that let's say for one row in table A, how many matching rows are there in table B, right? So for one row in table A, how many matching rows are there in table B? Get it? Right? So we understood that a relationship is a connection or the bridge, right? But the cardinality says the type of connection, how many rows are involved on each side. So imagine a bridge between two cities. Cardinality tells you if it's a one lane bridge, right, or a highway, or a messed up traffic, right? So if it's a one lane bridge, you would say that it's a one to one cardinality. If it's something like highway, it's one to many, right? And if it's a chaotic traffic, then you would say it's many to many, right? It's all about how the traffic is flowing and how many rows from table A travel to table B, right? How the rows are traveling from table A to table B, right? So that's basically the flow of your traffic or flow of your rows from one table to another table is your cardinality. So let me try to show you a few examples in cardinality. Before that, where would you find this cardinality? Again, you have to double click on this connection and you will get an option of edit relationship, where you will get cardinality as well as cross filter direction, and you can just toggle down this option and you can see the type of cardinality you want to go ahead with, whether you want to go with one to one, if it's a one lane flow of rows, if it's highway, or say one to many, you go ahead, choose one to many, and so on, right? So this is where you can actually see the cardinality, and let's quickly once see the example for a better understanding. I've got a table here. I try to create a table here with type of connections of different cardinality, right? So for one-to-one connection, just think it this way, that each employee has one computer, right? Employee ID linked to their asset ID, right? Each employee gets one laptop, one headset, one USB port, and so on, right? So that is one-to-one. What's one to many? One customer can have many orders. Customer ID linked to order ID. What's many to one? So one to many and many to one is kind of similar. It's just the flow direction is changed, right? So many products belong to one category. Your product ID linked to category ID, right? What's many to many? The same example that we had taken earlier, student and subjects, or student and courses. Many students enrolled in many courses, and many courses may have, right, many students, right? So this was our example of cardinality, right? So I believe we are good with types of cardinality that we have seen over here. Also, when we load the data or when we drag and drop to create a relationship, then Power BI automatically counts rows on each side and then gives you a cardinality automatically, right? So when I go ahead and drag and drop and create a connection, or whenever I am loading the data from Power Query to Power BI, right, then the system will automatically count the number of rows in each table, right, and it'll give you a cardinality automatically. But still, if you think that needs to be fixed, then you can go ahead and change it, right? And why would we want to change that? Because if Power BI is doing automatically, then why would anyone want to mess that up, right? Then in that case, the reason is that performance optimization is a one big key factor, right, which may want us to revise our cardinality at times, at rare times, I would say. Not always, but if you have a very complex data set with you and your data modeling is pretty complex, then you would want to revise your cardinality manually, right? Why? Obviously to make or to have a faster performance, right? So this was our cardinality over here. Now what's up with this direction of relationship? We have seen how tables are connected, that is relationship. We have seen the flow of rows from one connection to another connection, that is cardinality. Now what is this direction of relationship, or called the cross filter direction? What's up with this one, right? So imagine that you have given a connection. Now you are trying to give power to a table. Like, imagine it this way, that who or which table has a power to ask question, okay, right? So think of it this way, which table out of these two has more power to ask questions, right? So in technical term, it's more like how filtering works, right? So let's take this example itself. You see the direction, right? You see the direction over here, you would see the flow of direction is from customers to sales, right? Customers to sales, right? It's flowing from customer to sales, right? So let's say I want to filter the city with respect to sales. Okay, I want to filter cities and their total sales. Then I can filter it that way. But let's say I want to filter the date. Okay, I want to filter the date, that is here, rate of sale, right, with respect to the cities. Then that will not be possible, right? Why? Because the direction flow is from customer table to sales table. It will just not apply filters on date column over here, right? Why? Again, because the power is given to the customers table, right? So if, right, we can change the cross filter direction from here. Again, we click on the hover over here on the connection and double click it. You will get edit relation option, and you can edit your or change your filter direction from here. Okay, so what I was saying, so if I can if it's a single filter direction, I can filter the sales through city. Why? Because customer table has power. The direction is flowing from city from customer to sales. But if I want to filter the sales on basis of date, I cannot do it because because of the direction of the flow. But what if the cross filter direction had, instead of single, have had bi-direction? If you click on this, you can toggle down the options and you can choose bi-directional or both, right? If you would have selected both, then yes, the sales table also have the same amount of power to filter the data as your customer tables have, right? Then you could have easily filtered the sales and cities on the basis of date, right? Now 99% of the time, 99% of the scenarios or your projects, you will work with single cross filter. Only 1% or very rare scenarios or projects you will be using bi-directional or both direction cross filter direction, right? Only when the situation is too complex, you'll be going ahead with bi-direction. And that too, we need to be very, very sure that that we are going ahead with bi-direction, because if we create one bi-direction situation or connection, right, and like that we go ahead and we think that no, one is not causing any harm, let's go ahead and create another one, let's go ahead and create a third connection with bi-direction, right? But they are unnecessary. What will happen? It's a big time performance killer for Power BI. Just like our cardinality, if we go ahead and mess up our cardinality, it'll be a performance killer. Same way, the bi-directional filter is a performance killer, right? So it's very important to be careful. And another point is that if you go ahead and apply a bi-direction where it's not required, then when you're doing a visualization, when you're creating a report, when you're creating a chart, then the aggregate and calculations can go completely wrong, right? So one, be very careful before you're choosing bi-direction filter, because first, it's a performance killer. Second, if it's not necessary, then it can mess up your aggregates and calculations when you're doing the charting and visualization, correct? Now this was our everything about relationship and cardinality. We have seen how tables are connected, that's our relationship. We have seen the different types of connectivity that we can give between two tables, that's our cardinality. And then we have seen which table gets the more power to filter out the data, that's our direction of that depends on our direction of relationships, and that is our cross filter direction, right? And next we will be jumping on schemas and seeing what this schema is about, right? So schemas. So in this we have star schema and snowflake schema. Nothing too much complex in this one, so easily to understand. It's schema is just a structure of how you place or organize your fact and dimension table, right? So here in star schema, you would see that you have your fact table, right? In middle, remember fact table we discussed earlier, fact table with the quantitative values, right? So that goes in middle, and around the fact table you have dimension table connected to this fact table. Multiple dimension tables you have connected to this fact table. Now star schema is easy to use and simple. This structure gives denormalize the data. Alright, we'll discuss what's denormalize and normalize. Next up we have this snowflake schema that you see over here, right? Now in this, if you see, what's the difference? It's again same fact table surrounded by dimension table, but the difference that you would see over here is the dimension table is again right broken into again different tables, right? This structure is this structure normalizes the data, right? Now let's quickly understand what do I mean when I say denormalized and normalized in Power BI. So a quick analogy, right? If you have done machine learning, you would know that there is a concept of principal component analysis, PCA, where we remove the unnecessary features but make sure that the information is not repeated, right? That is your normalization over there. But here, right, in Power BI, what we do is, in Power BI, the normalization is splitting tables furthermore to remove unnecessary information, right? This is our uh, you know in Snowflake schema, we are splitting the dimension table into another table so that we are removing the unnecessary information, and that's why Snowflake schema is normalizes the data. Even in principal component analysis in machine learning, we go ahead and we remove the columns and make sure that the information is not repeated. We have 100% of information, but we remove the columns and make sure that the no information is repeated again and again. Same way, we are not removing anything, rather we are splitting the dimension table into another table, right? Why? Because we do not want repeated information, right? And that is normalized data. Okay, now, so that was normalization in Power BI. Now what is denormalization, right? Now denormalization is, your flat straight data, your fact table is connected to dimension table, nothing else, nothing in between, nothing after dimension table, just your fact table connected to your dimension table, right? So now you would be surprised to know that Power BI actually works much more better when the data is denormalized rather than a normalized data, right? The Power BI works much more better when the data is denormalized. So in short, again, because this can be confusing, let me just repeat everything again. So star schema, which is denormalized data, is fast in performance and easy to use, but the data might or will repeat. But in Snowflake schema, which is normalized data, this occupies less storage space and has clean relationships, but no data repeats, but it is low in performance and be complex to use, right? So remember this part and you'll be good to go, right? So this was our schema, right, so far. And star schema and Snowflake schema, you have multiple schemas to learn about, but these two are good to go ahead if you are first time learning about schemas, right? And then we have performance optimizations. So let's go ahead and see or talk about performance optimization in Power BI. Now there are many ways we can work on, for performance optimization in Power BI, right? But when it comes to data modeling, right, and when it comes to data modeling and when it comes to these topics that we have discussed, right, these are the 3 points that I could think of for a better performance optimization, right? Let's start with discussing the first one, which is make columns simpler, right? Or what I mean with that is, first work on to reduce the cardinality, right? That means make columns simpler. That's it, right? If let's say you have a column with lakhs or millions of different values, then that leads to high cardinality, right? So we need to make that, less cardinality. We need to reduce the cardinality, and how we can do that? We need to make the columns simpler, right? So we need to work on to have fewer unique values. Instead of having multiple different values, we need to have fewer unique values, or remove columns which we will not use for calculations, or for visuals in Power BI, right? So we can just remove them. They are not of no use to us, right? That's point number one. Point number two is, as we had discussed, that avoid bi-directional filters unless necessary. We had discussed this when we were talking about cross filter direction. So avoid bi-direction in cross filter unless very necessary, right? That's the second point that we have got over here. And third one is avoid showing raw data in charts. Now what do I mean by avoid showing raw data in charts? So it means that we use summarized tables for faster processing. So instead of just throwing anything to Power BI that, hey, go ahead and do make a report for me, no, we're not going to do that. We are getting the data, we do some EDA on it, right? We clean it, then we go ahead and summarize it. How do we summarize or aggregate it? We use group by, or we have options to aggregate the values, or we can drill through the data to have much more detailed information, right? So this is the third option, that you group by. So you have got, let's say, multiple cities, okay, Hyderabad, Mumbai, Bangalore, Delhi, all these things. You have got sales, you summarize it. Okay, Hyderabad for the month of this week, this month sales, Mumbai, this month sales. You group by, you aggregate them, you summarize them, right? You do not throw raw data for the visualization or for the reporting purpose, right? So that's the third point that we need to take care of. Also, when I say that create a table, that remember that even they say, if you're importing a CSV file into your Power BI, right, then always make sure that the data inside your CSV is in a table format, right? Why? So that when you load it in Power BI, you'll have a much more faster processing, right? So, and obviously all these things make sense when we are working with millions of data, right? The size of the data is pretty huge. So all of these things definitely make sense when we are working with such big data sets, right? So I believe this was it, and what we have covered over here in data modeling, right? I hope this was helpful for anyone who is viewing this video, and if you have anything to discuss, you can comment down, or you can reach out to me on my email or LinkedIn. If you have watched till end, then thank you so much for watching, and see you soon.